Hi everybody, welcome back. We are now looking at inverse variation problems again and how to solve them. So notice that this first sentence here is going to be our sentence that will translate into an equation. So, and the key word again, the key phrase that allows us to identify this as the correct one is the fact that it varies inversely. So, the time required to pick up trash along a stretch of highway, that's a lot of words. We're really just talking about time. Everything else is explanation about what time we're talking about. Varies inversely. Again, it's going to be our equals K. Then the number of volunteers who are working. Again, number and then of volunteers who are working is just a description to tell you what the number is about. So, for N equals number. So when we write this is going to be T equals K, and then since it's inversely, we'll write this over N. So that's step one for our four-step procedure from our solving direct variation video. So now we need to figure out what K is. Well, we know that if we have 12 volunteers, cleanup can take 4 hours. So when T equals 4, that should be T equals 4. We know that the number of volunteers is 12, so we plug that information as 4 equals K over 12. So K in this case is 48. So now we'll take this 48 and plug it in for K in the original equation, and we will get that T is equal to 48 over N. And now if you give me a time or a number of people, I should be able to give you the other quantity. So here we have how many volunteers are needed to complete the cleanup in 1.5 hours. So the question is, what is N when T equals 1.5? So we have 1.5 equals 48N. We cross multiply and we get 1.5N equals 48. So we divide both sides by that. We get 48 divided by 1.5, and we get 32. So it would take 32 people to take an hour and a half to clean the same stretch of road as it would take 12 people to do in 4 hours. So that is our problem. We'll see you next with joint variation.